In this video, we're going to focus on induction divisibility problems, like this one. Prove that 6 raised to the 4n plus 4 is divisible by 5 for all positive integers n. So how can we do that? Well, there are some basic steps that you need to be familiar with. So step 1 is that we need to prove that the statement is true when n is equal to 1. So that's the first thing we need to do. In step 2, we need to set n equal to k, and we need to assume that the statement that we get from that expression is true. Now, in the third step, this is going to be the final step where we're going to prove that it's divisible by 5. So what we need to do is replace n with k plus 1, and we're going to prove that the expression 6 raised to the n plus 4 is divisible by 5. So we can say that the statement s sub k plus 1 is equal to 5 times some integer l. If we can show this, then it means that this expression, and thus the original expression, is divisible by 5. Because if you divide 5 multiplied by some integer by 5, you're going to get that integer. So 5 times any integer, whatever that is, will always be divisible by 5. So for this particular example, once we replace n with k plus 1, we need to show that that particular expression is equal to 5l. And once we do that, we have proven that the original expression is divisible by 5 for all positive integers n. Now let's go ahead and work on this problem. So step 1 is that we need to prove that the statement is true for the first term. Now what is the first term? Well, notice what the problem says. We need to prove that 6 to the n plus 4 is divisible by 5 for all positive integers n. So what's the first positive integer? This would be n equals 1. So let's prove that the statement is true for n equals 1. So we have 6 raised to the n plus 4. And if we replace n with 1, it's going to be 6 to the first power plus 4, which is equal to 10. And we know that 10 is divisible by 5, because if you divide 10 by 5, it will give you an integer, which is 2. So we've proven that the first term, or that the statement is true for the first term. Now, our next step is to replace n with k. So we're going to assume that this is true. So instead of it being 6 to the n, it's going to be 6 raised to the k plus 4. And what we're going to do is we're going to set this equal to 5 times some integer, which you could use any letter, but we'll use m. If m is an integer, if you multiply it by 5, whatever that result is, will always be divisible by 5. Now what we're going to do is we're going to isolate 6 to the k. 6 raised to the k is equal to 5m minus 4. And so let's save this expression for later. Now in step 3, we're going to replace n with k plus 1. So it's going to be 6 raised to the k plus 1 plus 4. And our goal is to show that this is equal to 5 times some integer, which we'll use l to represent that integer. So now what is our next step? What we need to do is rewrite this expression. Now let's go back to algebra. What is x cubed times x to the 4th? You know this is going to be x to the 7th. So likewise, let's say if we have x to the 8, you can break it up into x to the 5 times x to the 3, because these two add up to 8. Likewise, what I can do here is I can split that into two parts. K plus 1 is basically k plus 1. So I can rewrite this 6 to the k plus 1 as 6 to the k times 6 to the 1. Now in the next step, I'm going to replace 6 to the k with 5m minus 4. So I'm going to have 6 times 5m minus 4 plus 4. I just decided to put the 6 in the front. Now let's distribute the 6. So 6 times 5m is 30m. 6 times negative 4, that's negative 24. And then plus 4. So that's going to give us 30m. And then negative 24 plus 4 is just negative 20. Now let's think about what we have at this point. Notice that m is an integer. So 30m minus 20 has to be an integer as well. Now I want this expression to equal 5 times L. So what I'm going to do is I'm going to factor out a 5 in this expression. So we could say that 6 raised to the k plus 1 plus 4 is equal to 5, and then times 30m divided by 5 is 6m. Negative 20 divided by 5 is negative 4. Now, because m is an integer, 6m minus 4 has to be an integer. So what we can do is we can let 6m minus 4 equal to some integer L. So thus, the expression 6 raised to the k plus 1 plus 4 is equal to 5L, which means that it's divisible by 5. And therefore, the original statement, 6 raised to the n plus 4, is also divisible by 5. And so that's how you can prove it using mathematical induction to show that it's divisible by 5. And you could test it out. If you plug in any number for n, it's going to be divisible by 5. Let's say if n is 4. 6 raised to the 4 plus 4. That's going to be 1300. And 1300 divided by 5 is 260. And so you could test it out by plugging in different numbers, but this is how you could show that this statement is true using mathematical induction. Now let's work on number 2. Prove that 7 raised to the n minus 2 raised to the n is divisible by 5 for all positive integers n. So let's follow the same process. First, let's prove that it's true when n is 1. So we have 7 raised to the n minus 2 raised to the n. And let's go ahead and replace n with 1. So this becomes 7 minus 2, which is 5. And 5 is divisible by 5. And so this is true for n equal 1, which is the first term for all positive integers n. Now let's assume that the statement is true when n is equal to k. And so replacing n with k, we have 7k minus 2 raised to the k. And we're going to set it equal to 5m, since we want to prove that it's divisible by 5. If we wanted to prove that it's divisible by 3, I would set it equal to 3m, where m is once again an integer. Now what I'm going to do is solve for 7 raised to the k. So I'm going to take this term and move it to the other side. So I have 7 raised to the k is equal to 5 times m plus 2 raised to the k. So let's save this expression for later. So now what we're going to do is we're going to set n equal to k plus 1. So this is going to be 7 raised to the k plus 1 minus 2 raised to the k plus 1. And we want to prove that it's divisible by 5. So we need to prove that this is equal to 5 times some integer L. That's our goal. So what I'm going to do at this point is break each of these numbers into two parts. So 7 raised to the k plus 1 is 7 to the first power times 7 raised to the k, just as we did before in the last example. And 2 raised to the k plus 1, we can write that as 2 to the first power times 2 raised to the k. So now I can replace 7 raised to the k with 5m plus 2 raised to the k because they're equal to each other. And so this becomes 7 times 5m plus 2 raised to the k, and then minus 2 times 2 raised to the k. 2 to the first power is the same as 2. So what do you think we need to do at this point? Our next step is to distribute the 7. 7 times 5m is 35m. And then 7 times 2 raised to the k, we're just going to write it as 7 times 2 raised to the k. Now, notice that we have a common term here. So what we can do is we can factor out the GCF, which is 2 raised to the k. So once we take out that greatest common factor, we'll be left with 7 minus 2. Seven minus 2 is 5. So we're going to have 35m plus 2 raised to the k times 5. So what do you think we should do at this point? Now remember, we want the original expression to equal 5L. So we need to factor out a 5 from those two numbers. So if we take out 5, 35m divided by 5 is 7m. And this expression divided by 5, the 5's will cancel and we'll just get 2 raised to the k. Now, both m and k are integers, which means this entire expression has to be an integer as well. So what we can do is we can let L equal 7m plus 2 raised to the k. So all of this is equal to 5L. So we can make the statement that S sub k plus 1, which was 7 raised to the k plus 1 minus 2 raised to the k plus 1, that's equal to 5 times some integer L, which means that the original expression is indeed divisible by 5. So let's pick an n value and test it out. Let's say if n is 6. 7 raised to the 6 minus 2 raised to the 6. Will that give us a number that is divisible by 5? Let's find out. 7 to the 6th power is 117,649. And 2 to the 6th power is 64. If we subtract those numbers, it will give us 117,585. And then if we divide that number by 5, this will give us an integer, which is 23,517. So regardless of what number you choose to plug in for n, it's going to be divisible by 5. And you could test it out if you want to. But that's basically it for this problem. So now let's move on to the next one. Number 3. Prove n times n plus 2 is divisible by 4 for all positive even integers n. So what do you think we need to do for this one? Well, first, we need to identify the first term. So positive even integers. That means n can be 2, it can be 4, 6, 8, 10, and so forth. We don't want to start with n equals 1 for the first term. If we try that, let's see what's going to happen. So it's going to be n times n plus 2, and so that's going to be 1 times 1 plus 2, which is 1 times 3, and 3 is not divisible by 4. We don't get a whole number. So n equals 1 is not the first term for this example. The first term is n equals 2. So we're going to start with that. If we replace n with 2, we'll have 2 times 2 plus 2. 2 plus 2 is 4. 2 times 4 is 8. And 8 is divisible by 4. So this works. Now our next step is to set n equal to k. So s of k, that's going to be k times k plus 2. Replacing n with k, and we're dividing it. We want it to be divisible by 4. So we're going to set it equal to 4m instead of 5m this time. Now, I'm not going to solve for anything just yet. So I'm going to move on to the third step before I rearrange this equation. So that's when n is equal to, should it be k plus 1 or something else? It's not going to be k plus 1, because notice that we're dealing with even integers and they differ by 2. So instead of making n k plus 1 for this example, it has to be k plus 2 for the next step, because the next term is 2 units higher than the previous term. So s sub k plus 2 is going to be associated with this expression. So replacing n with k plus 2, we're going to have k plus 2, and then we're going to replace this n with k plus 2 again. And so we'll get this expression. Our goal is to show that this is equal to 4 times some integer L. So let's simplify that expression. So this is k plus 2, and then we can add 2 plus 2, which is 4. So we get k plus 4. Next, let's FOIL. So k times k is k squared, and then k times 4, so that's 4k, and then we have plus 2k, and then 2 times 4 is 8. Now, what I'm going to do is I'm going to rearrange this expression. What I'm not going to do is I don't want to combine like terms. I don't want to add 4k and 2k to make it 6k. I'm going to write it as k squared plus 2k plus 4k plus 8. And here's why. Notice that if we distribute this expression, if we distribute k to k plus 2, we'll get k squared and then 2k, and that's equal to 4m. So therefore, since these two are the same, we can replace k squared plus 2k with 4m. And so that's what we need to do at this point. So we now have 4m plus 4k plus 8. So now we can take out 4. And so we'll be left with m plus k plus 2. And at this point, we're going to let L equal to m plus k plus 2. M and k are both integers, so m plus k plus 2 has to be another integer, which we'll call L. So this is equal to 4 times L if we replace this with L. And that's basically it. So s sub k plus 2, which was k plus 2 times k plus 2 plus another 2, all of that is equal to 4 times some integer L, which means that the original expression is indeed divisible by 4. And that's basically it. So that's how you can work induction divisibility problems. So that's all I got for this video. If you like it, feel free to subscribe to this channel. And I do have some other content if you need help in other subjects like chemistry, physics, algebra, trigonometry, calculus. If you need help in those areas, check out my channel. I have playlists with a lot of videos on those topics. Thanks again for watching.